the answers to page 46. These ones we did already yesterday, right? The 30 meters, right? Then there was that whole controversy about is this displacement or is this distance, that whole thing.
Yes.
Okay, these would be the correct graphs
What?
for 2, A, B, C, D, and E. Oh, they're not on there.
Yeah.
That's what I meant. I should probably give you the question, right? Or at least tell you what that graph is. Do you have that one?
Uniform motion forward.
Pardon me?
Uniform motion forward.
Uniform motion forward? That seems about right. Uniform motion forward. Uniform motion backwards. Which one's C? Speeding up forward. What does yours look like? Like that? Excellent. Remember, we're talking velocity time graph, right? So this one's what? Like that? I'm guessing that this is the E and this is F.
Oh, yeah.
2 Ds, yeah. How does that grab you? Good? Anything that I need to go through there at all? Okay, I think the next part you're supposed to put 5s on everything, right? Like that? Right?
Well, no. That's only because B should be 0 where you have a 5.
Yeah.
Oh, yeah, you're right. There's a little booba there, isn't there?
B.
Booba. Right, you are. That should be 0, and then that would be -5, right? Kind of like this. Okay, so for 3A, you should have an acceleration of 0. The displacement is 25. How do you get 25? 5 meters times 5 seconds. In other words, the area. And the velocity is a constant 5 meters per second, right? Constant 5. B, as Joey pointed out, that should be a 0, -5. So the acceleration is 0 because the slope is flat. The displacement is -25, right? Because it's below. And the constant velocity is -5 meters per second. And in C, the acceleration is 1. How do I get 1? Slope, 5/5. The displacement is the triangle, 1/2 times 5 times 5, or 12.5. And the velocity, now how do I do the average velocity here? You have to take the displacement, 12.5, divided by the time of 5, 2.55 meters per second. I'll pause there for a moment. Come on, I just want... Yes, my wayward son, let's go. D, E, and F. So, the acceleration is the slope -1. The displacement is the area, 5 times 5 divided by 2. And the velocity is 12.5 divided by 5, right? 2.5 again. Here the acceleration is -1, that's the slope. The displacement is 5 times 5 divided by 2, and the velocity is 2.5, which is 12.5 divided by 2. I think it's pretty self-explanatory now. Are we all good? Yeah, they're all very similar, right? Yeah. Kelani, you got to take those up, yeah, please. Now, I don't think I assigned number 4, did I? I did? Let's just do it. Generate a corresponding DT graph. So from the DT graph in figure 118. Yeah, I know. I hate when they do that too. 118, like that's like way back in the previous chapter, isn't it? Holy. Talk about lazy. Where's reprinted?
Thanks for that.
Yeah, there's one.
All right, well, on that, oh, it's right there. I made a copy of it for you. Okay, so what do? You find the slope at all those points by tangent line. There's only 3 of them. The slope there is 0. The slope there looks like to be 12. And the slope here looks to be 31. And then you just take that data and do what? Graph it, right? What's it going to look like? It's going to be like that, right? How do you get this slope? Oh, B? Well, you have to find 2 points. Yeah, it's not easy, is it? You're going to have to find 2 points, even if they're not a lattice point, right? You're going to have to, like that would be at 3, comma, maybe 28, right? And this one here might be at 1, comma, 10, about maybe 4 or so, right? And then find the slope, right? So it'd be 28 minus 4 all over, 3 minus 1, so it'd be like 24 over 2, which would be, oh, what do you know? I did it right. Oh. Man, am I smart. Y2 minus Y1 over X2 minus X1. Come back to you now? Okay. It is not, Michael. Bunch of junk.
So show me where you wrote the exam.
Oh, yeah.